Hello, AMC students. So, a lot of you are asking questions about logarithms and the graphs of logarithms. And so, in this video, I want to go through the long, painful process of graphing one by hand. And then in a separate video, I'll talk about looking at a graph that you're already given and trying to figure out the equation from that. So, kind of two different processes. And so, for this video, we're going to look at our good friend y equals log base 3 of x. And let's try to make an xy table. Now, one of the things about logarithms is there are very few numbers that I can do a logarithm in my head. I need to think about what are the powers of 3. And it's sometimes useful to just even think about the inverse function. The inverse function here would be 3 to the y is equal to x. Really, that's kind of the exact same function, just switched into exponential form. And so the different powers of 3 that I know are 3, 9, 27, 81. I can keep going, but I think that you'll get the picture after that. And I want you to notice that my powers of 3 are the x values, because it's the inverse of an exponential graph here. And I also want you to notice my x values multiply by 3 as I go to the right. So if I wanted to work backwards, my x value would divide by 3. And I could divide by 3 again, and I could divide by 3 again. I mean, let's do that real quick. Let's just write 1/3 here. We'll think about what y value makes sense there. Now, the y value is whatever power results in that x value. So what power of 3 results in 9? 2. 3 squared. 3 to the third is 27. 3 to the fourth is 81. And you see the pattern here. We're just counting up by 1 power because those were the x values I chose. 3 to the first power, 3 to the 0 power, 3 to the -1 power. Now take a second to look at those numbers. You should notice that this is the inverse of an exponential. The x values are increasing a lot, and the y values are increasing very slowly. Many of you are familiar with the exponential curve. Has an asymptote, a horizontal asymptote, and then it skyrockets. This is the inverse. Horizontal becomes vertical. Instead of skyrocketing, it is growing very, very slowly. So what I will graph for you is the logarithmic function. It's got an x-intercept here at 1, 0. Then I'll go all the way over to 3. Now I'm at x equals 1. Then we have to count all the way to 4, 5, 6, 7, 8, 9. And now we're at x or y equals 2. I misspoke just a second ago. Y equals 2. If I go to x equals 1/3, so I don't know right about there, then I'm at y equals -1. If I divide by 3 again, I'm at x equals 1/9, and now I'm at y equals -2. This is where that asymptote comes in. Rather than it being a horizontal asymptote, it's a vertical asymptote. Rather than it going to y equals 0 as your x's go left, this goes towards x equals 0 as your y's go down. And so this is your logarithmic graph. Logarithms grow very slowly. The bigger the base, the slower they grow. It's the exact opposite of an exponential function. And the reason is it takes longer to achieve the next power. If I had like a base of 10, I wouldn't even get to y equals 2 until I'm at x equals 100. And then at x equals 1,000, now I'm finally one step higher. So that is how you graph a logarithm by hand, is you choose x values that you can compute the exponent on. That's why I chose 1, 3, 9, 27, 81. And the y value is the power that gets you there. So it grows very slowly. In another video, I will look at a few logarithmic graphs and try to figure out the equations based on the graphs.